What if everything we can see, every star, every galaxy, every swirling cluster of light suspended in the night sky, and even the cosmic horizon itself, is just the smallest ripple on an infinite ocean we will never fully grasp? Imagine for a moment that our entire reality, everything humanity has ever measured, photographed, or dreamed of through the lens of a telescope, is not the whole, but only a trembling fragment, a surface shimmer upon something so immense that our minds can only circle around it like moths around a flame. When we tilt our gaze upward at night, we are like children staring through a keyhole, believing that the narrow scene framed by its edges is the entire theater. Yet behind the door is a world that sprawls endlessly, patiently waiting to be imagined. Take a deep breath, let the thoughts settle, and notice how even the idea itself begins to shift the ground beneath your sense of certainty. If all of existence as we know it is a ripple, a fleeting pattern in a cosmic sea, then what are we really looking at when we call it the universe? And more hauntingly, what lies just beyond the horizon we cannot cross? Our observable universe stretches a staggering 93 billion light years across. That number alone is difficult to wrap your mind around. If you traveled at the speed of light, the fastest anything in the universe can move, it would still take you 93 billion years to cross from one side of our observable realm to the other. By any measure, it feels infinite, an expanse so wide that the human imagination strains against its own boundaries. But here comes the twist, the quiet revelation that pulls the floor out from under us. This unfathomable span is likely just a small bubble within something far greater. The word observable is the key. We tend to forget that when astronomers use it, they are not describing the entire universe, only the portion we can actually see. Our cosmic vision is limited, and it has nothing to do with the strength of our telescopes or the brilliance of our technology. The limitation is built into the very fabric of space and time. Light has a speed, and even though it is unimaginably fast, it is not infinite. Since the universe began about 13.8 billion years ago, light has had only that amount of time to travel. In a sense, our cosmic vision is bound by a clock. Imagine lighting a candle in a dark room and waiting for its glow to reach the far corners. No matter how patient you are, the light can only reach so far in a given amount of time. Our universe is the same. We can see no further than the light that has had time to arrive since the beginning. Beyond that invisible wall, there may be galaxies, clusters, or even entirely new structures of reality, but their light has not yet reached us. They remain hidden, not because they do not exist, but because the universe has not yet had the time to reveal them. And yet, there is another complication. Space itself is not still. Since the Big Bang, it has been expanding, stretching like a balloon being inflated. Imagine placing two dots on the surface of that balloon and then blowing it up. The dots move farther apart, not because they are traveling across the balloon, but because the balloon itself is stretching beneath them. Now take that image and expand it to cosmic proportions. Galaxies drift apart, carried not by their own engines, but by the stretching fabric of space itself. This expansion means that the actual boundary of our universe is much farther away than the 13.8 billion years of light travel would suggest. Space has been stretching all along the way, carrying galaxies further and further as the light makes its journey. So, when astronomers calculate the true span of our observable bubble, they arrive at the almost incomprehensible number, 93 billion light years. That is the edge of what we can know, not because the universe ends there, but because light has not had time to bring us news of what lies beyond. Now, picture yourself floating in the middle of the ocean. The horizon stretches out in every direction, curving into a perfect circle around you. It feels final, like the end of sight itself. But you know the ocean does not end there. You know that beyond that horizon, waves continue, coastlines rise, storms brew, and other ships sail. Your inability to see them does not erase their existence. The observable universe is our cosmic horizon, and we are the small raft in its center. We cannot see beyond the curve, but we suspect, with good reason, that the ocean goes on without us. There is something profoundly humbling in this realization. For centuries, humans believed that our world was the center of all things, that the stars wheeled around us like jewels fastened to the dome of heaven. Then came the revolution of thought. The Earth was not the center, the Sun was. Later, even the Sun lost its throne, just another star in a vast galaxy. Then the galaxy itself proved to be one among billions. Each revelation pushed us further from the illusion of centrality. And now, even the universe we can see, the galaxies, the clusters, the grand sweep of 93 billion light years, is likely only a bubble in the dark, a fragment of a larger whole. Take a moment to think about this. If everything we have ever known fits into a bubble, then the true scale of existence might be so vast that the word infinite begins to lose meaning. We may be surrounded by realities we can never touch, neighbors whose light will never cross the gulf. In this view, the universe is not a stage where humanity plays a part in a single unfolding drama, but a labyrinth without walls, a place where the very notion of the whole slips out of reach. This challenges not only our science, but also our sense of significance. What does it mean to be human in a universe so large that our entire observable domain is just a bubble? Are we droplets of consciousness adrift in an ocean of endless bubbles? Or is there something uniquely profound about the very act of perceiving, of wondering, of recognizing that we are inside a bubble at all? Even as we marvel at the enormity, we must accept the fragility of our position. We are explorers confined within walls we cannot break, gazing outward with instruments and imagination, trying to glimpse what lies beyond. We know only a fraction, a small ripple, a shimmer on the cosmic sea. And that shimmer, as beautiful and awe-inspiring as it is surrounded on all sides by silence and mystery. But the story does not end here, because even inside this bubble, even within the limits of what we can observe, there are walls, invisible barriers that stop our gaze from traveling further back in time. If the universe itself is a bubble, then inside it are curtains, veils of light and matter that conceal what lies behind. To understand them, we must turn toward the first wall of light, a faint glow that marks both the beginning of vision and the end of sight. If our observable universe is a bubble in the dark, then the edges of this bubble are not smooth or transparent. They shimmer with a faint, ghostly glow, a veil of ancient light that stretches across the entire sky. This light is so uniform, so perfectly balanced, that you cannot see it with your eyes. It is everywhere, filling every corner of the cosmos, yet invisible to us without the help of instruments. Astronomers call it the cosmic microwave background, or the CMB for short, and it is often described as the oldest photograph in existence, a picture of the universe when it was only an infant. But calling it a photograph is both accurate and misleading. Accurate because the CMB is literally the first light that ever streamed freely across space. Misleading because unlike a photograph we might hold in our hands, it does not capture a crisp image of stars or galaxies. Instead, it is more like the afterglow of a fire that has just been lit, a lingering warmth that bathes the entire sky in soft microwaves, the faintest embers of creation itself. To understand why this light matters, we must journey back to a time before it existed. Imagine the universe as it was in its first moments after the Big Bang, a swirling storm of unimaginable heat and density. Space itself was smaller, matter was packed tightly together, and temperatures soared to extremes that words can hardly capture. In that furnace, light could not move freely. Every photon, every particle of light was trapped in a dense fog of charged particles. Electrons and protons, the basic building blocks of atoms, were not yet bound together, and so the cosmos was filled with a chaotic plasma. Photons collided endlessly with particles, ricocheting like frantic bees in a sealed hive, never escaping, never finding open space. This went on for nearly 380,000 years, a long infancy by cosmic standards. The universe was opaque, as impenetrable to light as the heart of a star. Imagine standing in the middle of a thick fog where every beam of light scatters before it reaches your eyes. No matter how sharp your vision, you cannot see through the haze. For hundreds of thousands of years, this was the state of the cosmos, a fog so dense that the idea of transparency, of light traveling freely, simply did not exist. Then, slowly, things began to change. The universe was expanding, and as it expanded, it cooled. Think of hot steam rising into the air and gradually condensing, turning into droplets, then into a clear sky. Around 380,000 years after the Big Bang, the temperature of the universe dropped enough for protons and electrons to join together, forming the first neutral atoms. With this union, the fog finally lifted. Photons were no longer trapped, no longer endlessly scattered. For the first time, light could move freely through space, traveling outward without interruption. This moment is called recombination, though the word is slightly deceptive, because it was really the first combination of particles into atoms. The light released at that moment is still with us today, stretched and softened by billions of years of expansion. What was once blinding heat has now cooled into a faint whisper of microwaves, invisible but detectable. That whisper is the CMB, the first wall of light, the boundary beyond which we cannot see. When scientists first detected this glow in the 1960s, quite by accident, they had no idea they were listening to the echo of creation. Two radio engineers, Arno Penzias and Robert Wilson, were testing an antenna when they noticed a persistent hiss, a background noise that would not go away. They cleaned the equipment, even shooed away nesting pigeons, but the noise remained. What they were hearing was not interference, but the universe itself speaking, its earliest light arriving after billions of years of travel. That discovery earned them a Nobel Prize and gave humanity its first real glimpse into the infancy of everything. The CMB is more than just a relic, more than just cosmic archaeology. It is also a map. Tiny fluctuations, small ripples in the otherwise uniform glow, reveal the seeds of structure that would one day grow into galaxies, stars, and planets. These slight variations in temperature, barely a fraction of a degree, are the fingerprints of the universe's earliest moments. To look at the CMB is to look at the blueprint of existence itself. Yet for all its gifts, the CMB is also a barrier. It marks the edge of what we can know through direct observation. Before that moment of recombination, the universe was opaque. No telescope, no matter how powerful, can peer beyond it. The light simply does not exist for us to see. What happened in those first 380,000 years, the true dawn of creation, is hidden behind that veil. We can only approach it indirectly, through mathematics, through theoretical models, through faint whispers in particle physics. The wall of light both reveals and conceals, like a curtain that lets us glimpse the stage but hides the machinery behind it. This duality makes the CMB one of the most haunting phenomena in all of science. On one hand, it is a treasure, the oldest light we will ever touch, a relic that has traveled across the ages to greet us. On the other, it is a reminder of our limits, a reminder that no matter how far we reach, there are doors in the cosmos that remain closed, perhaps forever. Think of it this way. The CMB is like the horizon at sea. You can look out and see where the sky meets the water, and it feels final, like the edge of the world. But you know it is not the edge, only the limit of your sight. Beyond it, more ocean stretches endlessly, though you cannot see it. The CMB is our horizon. It is as far as light can take us. Beyond it lies a world hidden in darkness, the first heartbeat of the universe, the true moment of birth. And so we are left with a paradox. The CMB gives us our most profound connection to the beginning, and yet it keeps the very beginning veiled. We have the photograph, but not the first act. We can trace the story of matter, but not the script of its opening lines. This tension between what is revealed and what is hidden is the essence of the cosmic mystery. Take a moment to sit with that thought, to know that the night sky above you, if you could see in microwaves, would glow with this ancient light, uniform and eternal, wrapping you in the same radiance that once filled the infant cosmos. To know that your eyes, though blind to it, are surrounded by the afterglow of the beginning. It is both comforting and unsettling, like hearing a lullaby sung by someone whose face you will never see. But the universe does not allow us to pause for long. Because as we step closer to that veil, as we study the CMB with finer detail, we begin to realize that even space itself refuses to sit still. Expansion continues, relentless, stretching the fabric beneath our feet, carrying galaxies apart faster than the speed of light, reshaping our understanding of what the cosmos truly is. If the cosmic microwave background is a shimmering veil that marks the horizon of our sight, then what lies beneath that veil is a stage that never stands still. The universe, vast and incomprehensible as it seems, is not a frozen sculpture. It is a living fabric, always in motion, always expanding. This discovery may feel simple today, something you read in a textbook or see on a planetarium wall, but it was once revolutionary, and it continues to challenge the very way we think about reality. For a long time, humans imagined the universe as eternal and unchanging. The stars seemed fixed, scattered across the black canvas of night, moving only in their regular dance of constellations. Even when Galileo first peered through his telescope, or when Newton explained gravity, the underlying assumption remained that the cosmos itself was steady, like an infinite cathedral, its architecture eternal. But in the 20th century, this illusion cracked. Astronomers noticed that the galaxies around us were not standing still. They were rushing away. The light from their stars stretched toward the red end of the spectrum, a cosmic fingerprint of retreat. It was as if space itself were a balloon, and every galaxy a dot on its surface. Inflate the balloon, and the dots all move apart, not because they are moving through space, but because the very fabric of space itself is stretching. Edwin Hubble's observations in the 1920s revealed this expansion, and suddenly the universe was no longer static. It was alive, dynamic, and restless. At first, it might sound like galaxies are simply flying away into empty space, but the truth is stranger. They are not moving through space the way a car moves down a road. Instead, the road itself is stretching beneath them. This difference matters because it means there is no edge, no boundary where the galaxies are rushing into something else. The universe is not expanding into anything. It is expanding into itself, stretching the distance between all things everywhere at once. And here lies one of the most astonishing truths of modern cosmology. The expansion of space is not bound by the speed of light. Einstein's cosmic speed limit applies to objects moving through space. But when the space itself grows, it can do so faster than light without breaking any rules. Galaxies beyond a certain distance recede from us faster than light, not because they are speeding through space, but because the space between us and them is swelling too quickly for their light ever to catch up. In a very real sense, there are galaxies we will never see, not because they do not exist, but because the universe is expanding faster than their light can travel toward us. They are forever out of reach, hidden not by walls or barriers, but by the restless growth of reality itself. When cosmologists began to measure this expansion in detail, they discovered something even stranger. The large-scale geometry of the universe appeared to be flat, not curved inward like a sphere, nor outward like a saddle. Imagine drawing a triangle in different spaces. On a ball, the angles add up to more than 180 degrees, while on a saddle, they add up to less. But in our universe, across unimaginable scales, the angles add up to 180 degrees exactly. Flat, balanced on the knife edge between curvature and openness. This flatness is not just a geometric curiosity. It carries with it a profound implication. A flat universe suggests that the cosmos might be infinite, stretching endlessly without end. A finite sphere has boundaries, a closed form, but a flat sheet can go on forever. If the measurements are correct, then what we see as our observable bubble may be just a tiny patch on an infinite quilt, a speck on a surface that has no edge. To think about infinity is to feel the floor drop away beneath you. Numbers can grow as large as you like, but infinity is not just another number. It is an abyss, a concept that swallows every attempt to grasp it. A universe without edge, without outside, without boundary, is a haunting idea. Where does it begin? Where does it end? The answer may be nowhere and everywhere. If you could travel in one direction forever, you might never come back around. You would simply keep going, endlessly, with no horizon to close the loop. This idea stretches our imagination as much as it stretches the fabric of space. For if the universe is infinite, then every possibility, every arrangement of atoms, every pattern of stars might repeat somewhere, sometime, across the endless expanse. Infinity has room not only for countless galaxies, but for countless versions of galaxies. Countless versions of us, living out lives indistinguishable from our own, scattered across a limitless plane. Take a moment to feel the strangeness of that. The night sky, already vast, may be just a single window in a house that never ends. Every cluster of stars you see might be mirrored in infinite variations, each one glowing quietly in the unreachable dark. In such a universe, our bubble of 93 billion light-years is not a cathedral after all. It is a droplet in an infinite ocean, small enough to vanish without notice. And yet, even as we contemplate this infinity, we must confront the irony of our situation. We can measure flatness, we can infer expansion, we can trace the outlines of the cosmos, but we cannot step outside our bubble to see the whole. We live trapped in the observable, aware of the possibility of infinity, but unable to prove it. The universe teases us with mathematics and evidence, but it does not hand us certainty. We are left suspended between the finite and the infinite, gazing into the void and wondering which it will be. Infinity, if it exists, changes everything. A finite universe suggests origin and limit. It implies a cosmos with a story that can be told from beginning to end, but an infinite one leaves us with no boundaries, no edges, no narrative that closes neatly. It becomes a landscape where beginnings blur into endlessness, where endings are illusions, and where every attempt to capture it is like trying to hold the ocean in your hands. Perhaps that is why the discovery of expansion feels so unsettling. The universe is not content to sit still. It stretches and grows, carrying us with it, expanding into a mystery we can never fully map. And somewhere beyond the galaxies we can see, the fabric races away faster than light, into a darkness we will never touch. Pause here for a moment and let that reality sink in. Every second you breathe, every moment you live, space itself is stretching beneath your feet. The galaxies you see tonight are not where they were yesterday. The cosmos itself is flowing, restless and unbound. You are living not in a static picture, but in a moving ocean, always expanding, always becoming. But if infinity surrounds us, if the universe stretches without end, then why do some galaxies move as if pulled by something beyond even that? There is something profoundly unsettling about watching the universe move in unison. For most of history, astronomers believed that galaxies scattered across the cosmos drifted randomly, each pulled by the tangled web of gravity within its neighborhood. Local motions made sense. Clusters drew galaxies inward, superclusters tugged at clusters, and the grand dance of matter seemed contained within the boundaries of our observable bubble. But in the late 2000s, a discovery rippled through the scientific world, one that hinted at something stranger, deeper, perhaps even otherworldly. Astronomers noticed that vast clusters of galaxies were not simply drifting about according to the familiar script of gravity. Instead, they seemed to be moving together, as though choreographed by a conductor we could not see. This peculiar motion was given a name that sounds almost poetic, yet carries a whisper of menace: the dark flow. The galaxies were not just drifting gently either. They were racing. Imagine an entire fleet of cosmic islands, each filled with billions of suns, all moving together at speeds approaching 2 million miles per hour. And they were not moving toward something visible. They were being drawn toward a hidden region, a place beyond our cosmic horizon, into a darkness we cannot observe. It is hard to overstate how strange this is. Within the boundaries of our observable universe, gravity accounts for the push and pull of cosmic structures. We can map dark matter, trace the filaments that weave galaxies together, and explain most motions by the unseen scaffolding of the cosmos. But the dark flow does not fit. It cannot be explained by the gravitational landscape within the bubble we inhabit. It points instead to an influence outside our view, as though the observable universe is only a small theater, and behind the curtains lies a vast machinery whose presence we can only infer. One possibility is that these galaxies are being tugged by an enormous structure beyond our horizon. Something unimaginably massive, perhaps a wall or supercluster so large that it dwarfs anything we have ever known, exerts its pull on matter inside our bubble. But if that is the case, then it means the cosmos is stranger than we dared to believe. Structures larger than anything inside our universe may exist out there, in realms forever hidden from our sight. Another possibility takes us further into speculation. Perhaps what we are seeing is not just a structure, but an echo of other universes, brushing against our own. In some versions of the multiverse theory, our universe is just one bubble among many, each floating in an infinite froth of creation. If two bubbles come close, their gravitational fields might tug on one another, even across the invisible boundary of our horizons. The dark flow, then, might be the faint whisper of another cosmos, its presence leaking into ours like a shadow seen through frosted glass. Take a moment to picture it. A trillion suns, bound into galaxies, bound again into clusters, all racing in unison toward a place no telescope can ever reveal. It is as though the universe itself has a secret, a hidden attraction it cannot share with us. We watch the galaxies move, but we cannot see the hand that pulls them. This is where science brushes against the edges of philosophy. For what does it mean if there are structures beyond our cosmic horizon, influencing us but forever invisible? What does it mean if other universes lie just beyond reach, leaving only faint imprints on our own? We often imagine science as the pursuit of certainty, but discoveries like the dark flow remind us that science is also the study of shadows, the attempt to map what cannot yet be seen, to give language to mysteries that resist explanation. Some astronomers urge caution. The evidence for dark flow is contested. Measuring the subtle motions of galaxies across billions of light years is enormously difficult, and not all agree on the data. Perhaps what we are seeing is an illusion, a misinterpretation of the cosmic background. Perhaps, in time, the flow will vanish under the weight of better observations. And yet, even if it fades, the idea it introduces will remain. The notion that something outside our bubble could tug on us lingers like a ghost, impossible to banish completely. If dark flow is real, it forces us to confront a humbling truth. We are not in the center of a neat, self-contained universe. We are inside a fragment of something larger, something that spills beyond the boundaries of our perception. Just as the ocean extends far beyond the horizon of a small raft, so too does the cosmos extend beyond the horizon of our observable bubble. The dark flow is like a wave felt beneath the raft, a sign of deeper currents we cannot chart. And perhaps that is why it captures the imagination so powerfully. It is not simply a technical anomaly in cosmic motion. It is a reminder that our universe has edges of ignorance, and beyond those edges lies the possibility of the infinite. It whispers that we may not be alone in the vastness, not just in terms of life, but in terms of entire realms of existence, entire universes that leave only the faintest fingerprints on our sky. Pause with that thought. Entire clusters of galaxies, billions of suns, racing together toward an invisible destination. They do not know why. They cannot resist. They are carried along by forces beyond their control, just as we are. And as we contemplate their motion, we find ourselves wondering whether the same unseen currents carry us too, tugging not only at matter, but at our very sense of reality. The mystery deepens when we recall that our only evidence for dark flow comes not from what we see directly, but from the scars it may leave upon the cosmic microwave background itself. If the galaxies are rushing toward a hidden realm, then perhaps the echoes of their motion are imprinted on that ancient wall of light, etched into the afterglow of the Big Bang. To search for dark flow is to search for those scars, for the faint disturbances in the veil that might hint at what lies beyond. And so the story leads us onward. From the discovery of galaxies fleeing faster than light, to the revelation of a flat, perhaps infinite cosmos, we now arrive at a mystery that seems to reach beyond even infinity. For what could lie outside an infinite universe? What hand could tug at galaxies if not a force from another reality altogether? Perhaps the clues lie etched on that ancient wall of light, in strange scars burned into the fabric of the CMB. When we look at the cosmic microwave background, that faint afterglow of creation, it is tempting to think of it as smooth and uniform, like a delicate veil stretched across the sky. For the most part, it is. The variations in temperature are tiny, differences of only 1 part in 100,000, gentle ripples that mark the seeds of galaxies. But then, hidden in this otherwise tranquil sea, we find something strange, something that should not be there. It is a blemish, a bruise, a patch of cold that refuses to blend in with the rest. Astronomers call it, with simple honesty, the cold spot. At first glance, it might seem like a small irregularity, a patch slightly cooler than its surroundings, stretched across an expanse of space much larger than our galaxy. But the cold spot is not merely an aesthetic oddity. It is a riddle that has resisted explanation for decades. It stands out like a scar, an imprint etched into the very skin of the universe, whispering of forces we do not yet understand. To appreciate its mystery, we must understand what the cosmic microwave background usually tells us. Those faint ripples of temperature are thought to be the fingerprints of quantum fluctuations, magnified by cosmic inflation in the first fraction of a second after the Big Bang. They are random, statistical, messy, and yet, when viewed across the whole sky, they follow patterns that make sense. But the cold spot does not fit the pattern. It is too large, too distinct, too coherent to be explained by the usual randomness of quantum beginnings. So where did this cosmic bruise come from? One idea is that it is the shadow of a great void. Imagine a vast region of space nearly empty of galaxies, a cosmic desert stretching for hundreds of millions of light years. Light passing through such a void would lose energy, cooling slightly by the time it reaches us, and leaving behind the faint impression of a cold patch. But when astronomers searched for such a void, they found only hints, nothing large enough to explain the anomaly. The cold spot remains colder, sharper, and more stubborn than a void alone can account for. Another possibility is that dark matter plays a role. Perhaps hidden concentrations or deficits of this invisible substance distort the flow of light in ways we do not yet understand. But again, the evidence resists neat explanations. Dark matter bends, warps, and magnifies, but it does not easily leave behind scars of this scale. The cold spot stands apart, refusing to be explained away. And then there is the most haunting idea of all. Perhaps the cold spot is not a void or a quirk of statistics. Perhaps it is a bruise left by contact, a mark where our universe brushed against another. In some versions of inflationary cosmology, universes are born not singly, but in bubbles, expanding within a larger froth of eternal inflation. These bubbles can grow vast, and though each one is separated by inflating space, collisions are not impossible. If two universes brushed against one another in their early stages, the collision would leave behind a scar, a wound frozen into the background radiation. The cold spot in this view is not just a patch of emptiness. It is a memory of violence, a trace of another cosmos imprinted upon our own. Take a moment to let that possibility sink in. The cold spot might be evidence that our universe is not alone. That long before galaxies formed, before the first stars ignited, before planets spun into being, our cosmos collided with another. The evidence of that encounter is still with us, painted faintly across the sky, a whisper from another reality that touched ours and left a mark. If this is true, then the cold spot becomes one of the most extraordinary discoveries in all of science. It would mean that our universe is not self-contained, not solitary, but part of a greater multiverse where collisions between realities can occur. The implications are staggering. It would mean that the physics we know is only local, that beyond our horizon, other universes may play by different rules, with different constants, different laws, perhaps even different versions of time itself. And yet, as always, certainty slips through our fingers. Some scientists caution that the cold spot might be nothing more than a statistical fluke, a coincidence in the random distribution of cosmic ripples. After all, in a universe as large as ours, improbable things will happen. Perhaps this bruise is not a scar from another cosmos, but simply an accident of randomness. Perhaps we are reading too much into a shadow. But whether it is a fluke, a void, or a scar from another universe, the cold spot forces us to confront the fragility of our knowledge. We live inside a bubble, trying to reconstruct its history from faint whispers of radiation, from fragile traces left over billions of years. Our evidence is subtle, our tools limited, and yet the questions we ask are enormous. What if this scar is real? What if our universe once touched another? What if we are part of a vast froth of bubbles, colliding and separating, each one its own cosmos, its own reality? Pause with that thought. Imagine standing on the shore of a dark ocean, waves rising and falling beyond sight. Every so often, two waves crash together, leaving behind a scar in the water's surface. The cold spot is such a scar, but written not in water, not in sound, but in the very fabric of space and time. It is a reminder that our cosmos may not be alone in the dark, that the ocean of reality is vaster than we can see, and that sometimes the waves collide, leaving traces of their meeting in the foam. And perhaps in a way, this scar is a gift. It invites us to imagine, to question, to wonder about what lies beyond. It is a puzzle that keeps cosmologists awake at night, but also one that invites us to dream. to think of reality not as a sealed box, but as an open horizon. The cold spot is both bruise and beacon, both mystery and possibility. If universes can collide, if our bubble can brush against another, then the question arises naturally, can they also multiply, birthing new realms endlessly, spilling into existence without end? The cold spot may be a scar from one such encounter, but the story of cosmic inflation hints at something even more profound. It hints at a process that never truly stops, a process that keeps spawning universes like stars being born in the night. And if that is true, then our scar is only one clue in a much larger mystery, one that stretches far beyond the boundaries of our imagination. And if universes can collide, then maybe they can also multiply. What if the Big Bang never really ended? It is a startling question, because for most of us, the Big Bang feels like a singular moment, a one-time explosion that flung energy and matter into being and set the universe on its long journey towards stars, galaxies, and life. We imagine it as a beginning with a period at the end of the sentence. But what if that period is not a period at all? What if it is a comma, one pause in a sentence that never stops unfolding? This is the essence of eternal inflation, one of the most audacious and far-reaching ideas in modern cosmology. It begins with inflation itself, the theory that in the first fraction of a second after the Big Bang, the universe expanded at a rate faster than anything we can comprehend. Space ballooned outward, stretching quantum fluctuations into vast cosmic structures, smoothing the universe into the near-uniform expanse we see today. Inflation explains why the universe looks flat, why the cosmic microwave background is so even, why galaxies are distributed the way they are. But here's the twist. Inflation may not have stopped everywhere. According to eternal inflation, space is like a field of boiling water, bubbling and frothing endlessly. In some regions, inflation slows down and ends, creating a bubble where space stabilizes and matter and energy can form, what we would call a universe. But in other regions, inflation continues unchecked, stretching space ever outward, spawning more bubbles in the process. Each bubble is its own universe, with its own laws, its own constants, its own story. The froth never ceases. Bubbles keep forming, keep expanding, keep colliding, and the great boiling of reality has no end. Think of it as a cosmic foam, with bubbles endlessly inflating within a larger, inflating sea. Our universe is one bubble, vast to us, but only a tiny pocket in a froth that may be infinite. The Big Bang that gave birth to our cosmos is not unique, not singular, but one of countless such bangs, each one a bubble universe blossoming in the endless field of inflation. This vision is as humbling as it is mind-bending. It suggests that everything we know, every atom, every galaxy, every star and planet is not the universe, but simply one small room in an infinite mansion. And the other rooms may look very different. Some may follow physical laws so alien that we could not survive a moment in them. Imagine a universe where gravity is too strong for stars to form, where light cannot travel, where matter itself dissolves into chaos. Others might look eerily familiar, with galaxies, stars, planets, and perhaps even life evolving under laws much like our own. And then comes the strangest possibility of all. In an infinite froth of universes, with infinite variations of physical laws and conditions, there is room for repetition. There is room for worlds nearly identical to ours, for histories that play out in almost the same way, for versions of Earth where everything unfolds just as it has here. If eternal inflation is true, then somewhere in the cosmic foam, there may be another you, sitting in another room, listening to these words, wondering the same questions, dreaming the same dreams. Take a moment to think about that. Infinity is not just vastness, it is inevitability. In an infinite sea of universes, everything that can happen will happen, not once but endlessly. Every choice you did not make, every path you did not take, every possibility that flickered and died in your own life might be lived out in another universe, in another version of you. The multiverse becomes not just a scientific concept, but a mirror for our deepest hopes and fears. This is where cosmology and philosophy begin to blend. If there are infinite versions of you, what does that mean for identity? For meaning? Are you unique, or are you one thread in an endless tapestry of selves? Does the existence of infinite Earths diminish the value of our Earth? Or does it make this particular version all the more precious? A singular moment in your own lived reality, even if it repeats elsewhere. The human mind is not well equipped to grapple with infinity. We think in stories with beginnings and endings. We imagine edges, borders, and limits. Eternal inflation shatters that instinct. It suggests a reality that never ends, a process without boundary, a creation that is not an event, but an ongoing condition of existence. It turns the universe from a singular story into an endless library, each book its own cosmos, each page its own moment of creation. And yet, as with so many ideas in cosmology, eternal inflation remains just beyond the reach of proof. The evidence is indirect, suggested by the flatness of the universe, the uniformity of the cosmic microwave background, and the mathematics of inflation itself. We cannot step outside our bubble to watch others form. We can only trace the clues left within our own, hints that the story continues beyond what we see. Like the whisper of dark flow, like the bruise of the cold spot, eternal inflation asks us to look past the horizon of certainty and step into the realm of possibility. What makes this idea so haunting is its scope. It does not just change our picture of the cosmos, it changes our picture of reality itself. If the multiverse is real, then the word universe, once the name for all that exists, becomes misleading. Our universe is not the whole. It is only one chapter in a book that never ends, one bubble in an endless froth of bubbles, one verse in an infinite chorus. Pause with that thought. Imagine walking through a forest only to realize that every tree is a universe. You step back and you see that the forest has no boundary. It stretches on without end. Each tree a cosmos, each leaf a world, each breath of wind the birth of something new. This is the vision eternal inflation offers us. Not one creation, not one story, but an infinite flowering of worlds. But eternal inflation is not the end of the mystery. It is only the beginning. For as wild as the idea of infinite universes may be, physics whispers of even stranger possibilities. Beyond the foam of bubbles lie concepts that challenge even the imagination of science fiction. Realities where white holes spew energy instead of swallowing it. Where cosmic strings thread through space-time like cracks in the glass of reality. Where wormholes tunnel from one bubble to another. Where mirror universes may run time in reverse. And so, while eternal inflation may leave us dizzy with the thought of infinite worlds, the journey does not stop there. It opens the door to ideas even more radical, even more haunting, even more beautiful in their strangeness. But eternal inflation is only the beginning. Physics also whispers of stranger, wilder possibilities. When we look up at the night sky, we often imagine it as vast, yet familiar. Stars twinkle, galaxies spin, black holes lurk like cosmic predators. But theoretical physics hints at something stranger, a hidden architecture beneath the visible cosmos, full of impossible doors and unseen pathways. If eternal inflation paints a picture of infinite universes, then these exotic gateways offer the keys, however fragile, to step between them. Let us begin with the most curious mirror of all, the white hole. We know black holes well enough in theory, even if they remain wrapped in mystery. They are regions of space-time where gravity grows so strong that not even light can escape. Cross the event horizon and you are gone forever, consumed by the abyss. But if black holes swallow, what if there exists a cosmic twin that expels? That is the white hole, a theoretical object that spits matter and energy out into space, but cannot be entered from the outside. Imagine a fountain that flows only outward, never inward, forever spraying energy into the void. Some physicists have even speculated that the Big Bang itself could have been a kind of white hole, an eruption of energy from a deeper, hidden reality. White holes are not observed, at least not yet, and perhaps never will be. They may be mathematical curiosities, shimmering at the edges of Einstein's equations, but the idea is haunting. It flips our intuition about gravity on its head, transforming the universe from a one-way prison into a system that might breathe, exhaling creation as much as it inhales collapse. Could a black hole in one universe be a white hole in another, linked like two lungs of a cosmic body? It is a thought that dances on the boundary of physics and poetry. Next, consider the possibility of cosmic strings. These are not strings in the everyday sense, nor even the vibrating strings of string theory. Cosmic strings, if they exist, are defects in space-time itself, formed in the earliest moments of the universe. Picture the surface of an ice sheet, cracking as it freezes. Each crack is a fault, a flaw in the smooth surface. In the same way, cosmic strings would be immense one-dimensional scars left over from the birth of the cosmos, infinitely thin but carrying unimaginable mass. A single cosmic string stretching across the universe would warp space so powerfully that it could bend the path of light around it, lensing distant galaxies into strange arcs. Some theorists even imagine cosmic strings as bridges, threads that stitch different regions of space or even different universes together. They would not be gentle bridges. Touching one would be like touching the edge of infinity itself, a filament of pure gravitational energy. They could be relics of the deepest laws of nature, silent evidence of realities layered beneath the one we inhabit. Whether they are true scars from creation or simply whispers of mathematics, cosmic strings remind us that space-time is not always smooth. It can be torn, creased, and folded. And then there are wormholes, the most famous of the exotic possibilities. Wormholes are tunnels through space-time, shortcuts between distant points. They arise naturally in Einstein's equations, a solution where two throats of space-time connect like the ends of a tunnel. Step into one mouth, and you could, in theory, emerge on the other side of the galaxy, or even in another universe entirely. Wormholes are irresistible to the imagination. Science fiction is filled with starships plunging into their mouths, civilizations linked by networks of tunnels, travelers stepping across light years in a single instant. Yet wormholes come with their own riddles. Are they stable? Could they exist without collapsing into themselves? Some physicists suggest that exotic matter with negative energy would be needed to hold them open. Others argue that wormholes would instantly pinch shut, making travel impossible. Still, the equations leave the door open, and as long as they do, we are free to dream. A wormhole is not just a tunnel in space, but a tunnel in possibility, a reminder that space-time may have hidden passages we have not yet walked. Finally, imagine an entire cosmos where time itself runs backward. This is the strange vision of a mirror universe, a place where every process is reversed. In our universe, entropy increases. Eggs crack, but never uncrack. Stars burn fuel but never rekindle themselves from ashes. Time moves forward, dragging us with it. But what if, on the other side of the cosmic mirror, entropy decreases? Stars grow brighter instead of dimming. Eggs assemble themselves from fragments. Consciousness runs in reverse, remembering the future instead of the past. Such a mirror universe would not just look strange. It would be almost incomprehensible. Our very sense of existence, of cause and effect, would shatter. And yet, the mathematics of physics does not forbid it. At the most fundamental level, many of the laws of nature are time-symmetric, meaning they work just as well backward as forward. The arrow of time may be a property not of the laws themselves, but of the conditions of our universe at its birth, which raises the possibility. Somewhere in the froth of eternal inflation, there could be a universe where that arrow points the other way. Take a breath and let these possibilities wash over you. White holes, cosmic strings, wormholes, mirror universes. They sound like fiction, and perhaps they are. But they are born not from fantasy, but from the mathematics of physics, from equations that leave room for strangeness. They may never be observed, never be proven. But in imagining them, we stretch the boundaries of what it means to think about reality. We remind ourselves that the universe is not limited to what is comfortable or familiar or even observable. It is free to be stranger than anything we can imagine. The impact of these ideas lies not only in their scientific possibility, but in their philosophical weight. If wormholes exist, then distance itself is not a limit. If mirror universes exist, then time itself is not a certainty. If white holes exist, then beginnings and endings are not as simple as we thought. If cosmic strings exist, then reality itself is scarred, a fabric not smooth but stitched with flaws that whisper of deeper truths. These gateways, whether real or imagined, blur the line between science and story. They invite us to wonder, to ask not just what the universe is, but what it could be. They remind us that the cosmos is not a closed book, but an unfinished manuscript, with chapters still hidden, pages still unwritten, and margins filled with questions. And as wondrous as these doors are, they open onto an even greater question. For even if they exist, their nature may depend on the shape of space itself. The geometry of the cosmos, the very curve of reality, may hold the answer to what lies beyond. But even if these doors exist, what lies beyond them may depend on the very shape of space itself. When we step outside and gaze at the night sky, we instinctively assume that the universe stretches outward in straight lines. A vast, flat canvas where galaxies float like paint scattered across a cosmic mural. Our minds are trained to think in 3 dimensions, to see space as something like an endless room, with width, height, and depth unfolding without end. But physics tells us that this picture may be incomplete and perhaps even deeply misleading. The true shape of reality may not resemble the geometry we experience, and the very laws of physics may depend on it. The question sounds deceptively simple. Is the universe flat or is it curved? Yet answering this is like asking if existence itself bends, if reality itself has an architecture hidden just beyond our perception. To begin, consider the possibility of a flat universe. Cosmologists studying the cosmic microwave background have discovered that on the largest scales, the geometry of space appears remarkably even. Light traveling from distant galaxies does not bend wildly, and cosmic structures align in a way that suggests our universe is flat, like a vast sheet of paper stretched across the void. This flatness is not trivial. It means that parallel lines never meet, and triangles add up to the familiar 180 degrees, just as they do on Earth's maps. It implies a universe that might extend forever, infinite and boundless. But what if the cosmos is not flat, but curved? Imagine the surface of a ball, where lines eventually intersect, or the surface of a saddle, where lines spread apart. In a positively curved universe like the sphere, if you travel far enough, you could eventually loop back around to where you started. In a negatively curved one, shaped like a saddle, space would spread outward in an ever-diverging pattern, creating a geometry that is infinite, but bent in ways difficult for our minds to picture. Our 3-dimensional intuition falters here. To imagine curved space, we must think of space itself as a kind of fabric that bends, not into another dimension we can see, but into something more abstract. This is where theories like string theory step onto the stage. String theory suggests that the universe may not be confined to the 3 dimensions of space and 1 of time that we experience. Instead, reality could contain 10 dimensions, or even 11, curled up so tightly that we cannot detect them. Picture a garden hose lying on the ground. From far away, it looks like a 1-dimensional line, but up close, an ant crawling along it would discover another dimension, circling around its surface. In the same way, our universe could conceal extra dimensions folded in on themselves, hidden from our sight, but essential to the laws of physics. These dimensions might control the strength of gravity, the way particles interact, or even the very existence of matter. The possibility of hidden dimensions transforms geometry from abstract mathematics into the blueprint of existence. What we call the laws of physics may simply be the rules that emerge from the shape of the universe's geometry. In a flat, infinite universe, those laws may appear stable and familiar. In a curved or higher dimensional one, they could twist and shift, giving rise to phenomena that defy our expectations. Some physicists even speculate about realities where the fundamental forces behave in reverse. Imagine a universe where like charges attract instead of repel, where magnets pull together in ways opposite to our own. Imagine gravity pushing instead of pulling, scattering stars across the void rather than drawing them into galaxies. These are not just idle fantasies. They are possibilities encoded in the mathematics of geometry, in the ways dimensions can fold, bend, or expand. And here lies the profound, unsettling implication. Geometry is not just a tool for drawing shapes on paper. It is the architecture of reality itself. It tells particles how to move, tells light how to travel, tells energy how to flow. When Einstein revealed that gravity is not a force in the traditional sense, but the curvature of space-time itself, he opened the door to this deeper understanding. The universe is not a stage on which physics takes place. The stage and the play are one and the same. Space is not passive. It shapes everything, and it is shaped in return. Take a moment to reflect on this. Every step you take, every breath you draw, every moment you live is guided by the unseen geometry of the cosmos. You move forward because space is flat enough to allow it. You remain on the Earth because space-time curves enough to hold you. The stars burn because the geometry of the universe allows the forces of nature to balance just so. If the shape were different, even slightly, our existence might not be possible at all. And yet, the geometry we observe might not be the whole story. If eternal inflation is correct, then our observable bubble could be just one region among countless others, each with its own geometry. Some bubbles may be flat, others curved, others twisted into higher dimensional knots. In some, the laws of physics may allow life, in others, they may not. Geometry becomes not just a description of our universe, but the key to a multiverse of endless variation. There is something haunting in this thought. That reality itself is defined not by immutable rules, but by the contours of an invisible shape. That everything we know, from galaxies to consciousness, emerges from the way dimensions unfold. The question of whether the universe is flat, curved, or higher dimensional is not simply a question of math. It is a question of why we exist at all, why the cosmos allows us to be here, wondering at its mystery. As you let these possibilities sink in, imagine space as a silent sculpture, its curves invisible but omnipresent, its folds hidden yet decisive. We are like ants on the hose, perceiving only part of the whole, unable to see the deeper structure that guides us. Perhaps one day our science will reveal more, perhaps not. But even now, simply contemplating the geometry of the universe draws us closer to the heart of existence. And yet, even the emptiest vacuum may not be empty at all. When we hear the word nothing, we imagine an empty room, a blank page, or a silent void. Nothing is supposed to be the absence of all things, the clean slate against which existence is painted. But physics has whispered to us something deeply unsettling. Nothingness does not exist. Even in the most perfect vacuum, stripped of matter, stripped of light, stripped of every particle we can imagine, space itself hums with energy. It is not silent, it is not still. It is alive with a restless, invisible vibration. This hidden energy of space is called vacuum energy. At first, it sounds like a contradiction, an impossible riddle. How can emptiness contain anything at all? Yet when physicists peer into the mathematics of quantum theory, they find that what we call empty space is more like a stormy sea. Tiny fluctuations bubble in and out of existence. Particles appear and disappear, like fireflies blinking at the edge of perception. The vacuum is not a void, but a canvas of ceaseless motion, a field that thrums beneath reality itself. The scale of this energy is staggering. If we calculate the amount of vacuum energy predicted by quantum field theory, the numbers are beyond comprehension. The density of energy in nothing should be so great that space itself ought to curl up, collapse, or explode. The universe as we know it should not be stable. And yet, here we are. The stars shine steadily. Galaxies rotate. Planets trace their orbits as if held by invisible threads. Reality persists, even though the mathematics insists it should unravel. This puzzle is one of the greatest in modern physics, and it bears the name the cosmological constant problem. To understand it, imagine a guitar string vibrating. The tension in the string determines the sound it produces. If the tension is too high, the pitch rises and the song changes. If it is too low, the music fades into silence. The universe itself is like that string. The vacuum energy is its hidden tension. If that tension were even slightly different, reality would sing a completely different tune. If it were much larger, galaxies could not form. If it were smaller, the universe might collapse back into a singularity. Our existence depends on the vacuum's energy being precisely what it is, an exquisite balance that no one yet understands. Some physicists suggest that we may simply be lucky. In the endless bubbling of eternal inflation, countless universes are born, each with its own vacuum energy, its own cosmological constant. Most of these universes would be stillborn, collapsing instantly or expanding so quickly that matter never coalesces. But in a few, by chance, the vacuum energy lands in the narrow range that permits stars, planets, and life. We find ourselves in one of those rare pockets, not because it is special, but because only here could we exist to ask the question. Others see something deeper. Perhaps the vacuum is not random at all. Perhaps it is the fundamental stage upon which all universes play out their stories. In this view, the vacuum is not an absence, but the very fabric of being, a primal ocean from which all forms emerge. Just as waves rise and fall upon the sea, so too do universes rise and dissolve upon the vacuum. It is the hidden background, the silent painter whose brushstrokes we glimpse only in the structure of the cosmos. Consider for a moment what this means. Nothing is not empty. Nothing is pregnant with possibility. Every patch of space around you, every corner of the cosmos is filled with this invisible hum, this quiet energy. You are sitting inside it now, your body surrounded and infused by the restless sea of the vacuum. The atoms that make you exist not in isolation, but suspended in this field, like leaves floating on an unseen river. This realization is both humbling and liberating. It humbles us because it shows that what we thought of as solid and simple, the very concept of nothing, is far stranger and more complex than our intuition allows. It liberates us because it means that creation is not a rare, singular event. Creation is written into the fabric of reality itself. Every fluctuation, every ripple in the vacuum, is a reminder that existence emerges from the restless dance of what we call empty space. And this has profound implications for the multiverse. If vacuum energy can vary from one bubble universe to another, then each bubble may be painted in entirely different colors. In one, the vacuum energy may be high, scattering matter so widely that stars never form, leaving a cold, sterile expanse. In another, it may be low, pulling everything back together in a cosmic collapse. In still another, the balance may be just right, birthing galaxies and suns and worlds where life can arise. Each bubble becomes a canvas painted by the hidden brush of the vacuum. We, then, are children of nothing. Our world, our galaxies, our very consciousness all exist because the vacuum chose to sing a tune that permits complexity. This is not the nothing of silence, but the nothing of potential, of a canvas waiting to be filled, of a page waiting to be written. It is the paradox of existence, that everything comes from nothing, and that nothing itself is never empty. Take a moment to sit with this idea. Let it expand inside you like the quiet breath of the universe. The air around you is not empty. The space between the stars is not void. All of it hums with invisible energy, a secret heartbeat of the cosmos. To live is to dwell within that heartbeat, to ride the endless ocean of the vacuum. And if this is true, then the vacuum is not only the stage of the universe, but also its womb. Within this restless sea, black holes may grow into gateways. Within this invisible energy, universes may bud and blossom. Nothingness, it turns out, is the most fertile thing of all. And within this canvas, black holes may be seeds of entire new worlds. There are few things in the cosmos as terrifying or as mesmerizing as black holes. We think of them as monsters, cosmic abysses where light itself is swallowed, where matter is crushed into oblivion, where time stretches into eternity and ends. In every popular image, black holes are destroyers, engines of collapse that erase anything unlucky enough to wander too close. But what if that story is only half true? What if these creatures of darkness are not only graves, but wombs? Some physicists have suggested that every black hole could be the birthplace of an entirely new universe. It is a breathtaking idea, one that inverts our instincts. Instead of being the dead ends of reality, black holes may be hidden beginnings, seeds of creation wrapped in shrouds of darkness. To understand this possibility, picture matter falling into a black hole. To us, watching from the outside, it seems to disappear beyond the event horizon, the point of no return, never to be seen again. The equations of general relativity tell us that inside, matter collapses toward a singularity, a point of infinite density where the laws of physics break down. But some theorists suggest that the singularity may not be a true ending. Instead, it could be a doorway, a passage through which the collapsing matter rebounds into another dimension, another spacetime, another universe altogether. From the perspective of that newborn universe, the collapse we see as death would be experienced as a big bang, a burst of creation that expands outward, carrying with it all the energy and matter that once fell into the black hole. Imagine it. Every black hole we know, every one scattered through galaxies, every one at the centers of galaxies, could contain a universe hidden inside, vast and unknowable, blooming beyond the veil of darkness. And then comes the most haunting possibility of all. Our universe itself may be such a child. The Big Bang, that moment of radiant birth 13.8 billion years ago, may not have been the ultimate beginning, but the other side of a black hole in some parent cosmos. Perhaps our universe is only one branch on an endless family tree of universes, each born from the collapse of stars and galaxies in others. Reality becomes not a singular line, but a cosmic genealogy, a forest of worlds sprouting endlessly in the soil of darkness. This vision changes everything about how we see black holes. No longer are they the ultimate void, the devourers of matter, the silent destroyers. They become creators, mothers, midwives of new existence. They are not just the end of stars, but the beginning of universes. In their violence, there is fertility. In their silence, there is birth. The implications ripple outward in all directions. If black holes give rise to new universes, then the cosmos may be an endless cycle of collapse and creation. The death of stars feeds the birth of worlds. Each universe carries within it the seeds of countless others, a fractal garden of reality blooming within itself. Our own universe may someday collapse into black holes, and within those black holes, other universes may be born, each with its own laws, its own galaxies, its own possibilities for life. And consider what this means for us. If our universe is the child of another, then we are the grandchildren of stars that never shone in our skies, the heirs of laws written in another cosmos. We are living in a universe that may itself be the product of chance or of selection. Some theorists even imagine a kind of cosmic natural selection, where universes that give rise to many black holes produce more offspring universes, and thus become more common in the multiverse. In this vision, universes evolve, just as species do, favoring the laws of physics that maximize their fertility. Our universe, rich with stars and black holes, may be one of those fertile branches, part of a cosmic ecosystem beyond imagination. Pause and let this image sink in. Every black hole you have ever seen in a picture, every one drawn as a dark whirlpool surrounded by glowing matter, could be a window, though we can never pass through, into another universe. Inside those depths, hidden from us, may exist galaxies, suns, even beings pondering their own existence, unaware that their entire cosmos began in the collapse of a star in ours. The boundary between inside and outside, between destruction and creation, becomes blurred, as if the universe itself delights in hiding beginnings within endings. This idea also reshapes how we think of meaning. If black holes are wombs, then death itself is never final. The collapse of matter becomes the opening of a new reality. The universe is not a one-way journey toward decay, but a continual flowering, a recycling of existence into fresh forms. It suggests that what we call endings may be nothing more than hidden beginnings, beginnings too far away, too sealed behind the veil of space-time for us to glimpse. Of course, these are theories, not certainties. No telescope can peer inside a black hole. No probe can cross the event horizon and return. For us, the inside remains forever hidden. But sometimes the power of an idea lies not in its proof, but in the way it reshapes our imagination. To see black holes as wombs instead of tombs is to look at the cosmos with new eyes. It is to see creation not as something that happened once, long ago, but as something ongoing, something woven into the very processes of destruction. In this way, black holes become symbols as much as scientific mysteries. They are reminders that the universe is not what it seems, that the darkest places may hold the brightest secrets, that the story of reality is written in paradox. They force us to let go of the need for finality, for clean answers, and instead embrace the possibility that what appears to be an ending may simply be the opening of a door we cannot see. And perhaps this is the truest lesson of all. We live in a universe that hides beginnings inside endings, creation inside destruction, infinity inside darkness. To exist is to live in a cosmos that is endlessly recursive, endlessly fertile, endlessly mysterious. Black holes are not simply monsters waiting in the void. They are storytellers, whispering of worlds we will never touch, but can still imagine. And on even larger scales, gravity itself seems to be pointing us towards something unknown. Gravity is the most familiar of all the cosmic forces. It is what holds your feet to the ground, what binds the Earth to the sun, what weaves stars into galaxies and galaxies into clusters. Yet, on the largest scales, gravity reveals something far stranger than the gentle tug we experience each day. It seems to be pulling entire galaxies, clusters, and superclusters in one vast direction. as if there were a hidden hand on the other side of the universe, drawing us toward an unseen destination. This mysterious pull has a name, as poetic as it is unsettling: the Great Attractor. Discovered in the late 20th century, the Great Attractor is not a single object, not a bright beacon in the sky. Instead, it is a gravitational anomaly, a region of space whose influence is strong enough to drag our entire galactic neighborhood toward it. Imagine the Milky Way, along with hundreds of thousands of other galaxies, streaming through the cosmic ocean at hundreds of kilometers per second, all converging toward a place we cannot even see clearly. The pull is so immense that it distorts the flow of cosmic expansion itself, bending the motion of galaxies like leaves carried by a current. What lies at the heart of this pull? At first, astronomers suspected it might simply be a dense concentration of galaxies, a hidden cluster whose gravity outweighs everything around it. Yet the problem is that the Great Attractor sits in a part of the sky blocked by our own Milky Way, in what astronomers call the zone of avoidance. Our own galaxy's stars, dust, and gas form a veil across our line of sight, making it almost impossible to observe directly. The result is that we feel the pull, but we cannot see the source. Over time, surveys revealed vast structures, superclusters of galaxies, great filaments of matter, in the direction of the Great Attractor. But the more we looked, the stranger it became. Our galaxies are not merely drifting into this region. They seem to be streaming beyond it, as if being pulled towards something even larger, even farther away. Some call this deeper pull the Shapley supercluster, a colossal structure of galaxies that dwarfs anything near us. But others suspect that the mystery does not end there, that the flow of matter is pointing towards something beyond even our cosmic horizon. This is where the concept of dark flow enters the stage. In 2008, astronomers studying the cosmic microwave background noticed something peculiar. By analyzing how clusters of galaxies scatter ancient light, they found evidence that these clusters were all drifting together in a common direction, not just toward the Great Attractor, but beyond it, as if drawn toward some unseen mass outside the observable universe. This motion was not subtle. It suggested that galaxies were streaming at speeds of nearly 2 million miles per hour, all sharing the same cosmic destination. Dark flow is one of the most unsettling ideas in cosmology, because if it is real, it implies that the universe we see is being influenced by something outside the boundaries of our vision. Think of it like standing in a vast field, unable to see beyond the horizon, yet noticing that all the grass and leaves are bending in the same direction, as if a massive hidden storm were blowing beyond the hills. The cause is invisible, but the effect is undeniable. What could create such a pull? Some scientists argue it could be an enormous structure outside our observable universe, perhaps a supercluster of unimaginable size. Others whisper of even wilder possibilities. That dark flow is evidence of other universes pressing against our own, cosmic neighbors, whose gravity leaks across the border between realities. In this view, our universe is not isolated, but part of a grander multiverse, where the walls between worlds are porous enough for their mass to tug on us from the outside. Whether the cause is mundane or exotic, the mystery of dark flow forces us to face the limits of observation. We can map galaxies, we can measure radiation, we can trace the pull of gravity, but we cannot see beyond the edge of our bubble of light. Yet that edge does not stop reality. Something may exist out there, structures, universes, unknown forces, and their fingerprints are imprinted on the motions of galaxies right here. The Great Attractor and the dark flow remind us that we are not drifting aimlessly in a quiet void. We are participants in a much larger dance, pulled along by a cosmic rhythm we can only partly hear. Our Milky Way, with its hundreds of billions of stars, is not stationary. It is moving, carried on a current that streams across hundreds of millions of light years toward a hidden shore we may never reach. The emotional weight of this realization is profound. On one hand, it humbles us, reminding us that our position in the cosmos is not privileged. We are not at rest in the center of anything. We are swept up in motion so vast that our entire galaxy is just a single passenger. On the other hand, it stirs a kind of awe, a recognition that we are part of a story far bigger than we can perceive. We are voyagers on a journey with no clear destination, moving towards something we cannot name. This is the paradox of cosmic discovery. Each answer brings us closer to the edges of knowledge, and at those edges, we find only deeper mysteries. The Great Attractor is not just a region of galaxies, it is a symbol of the limits of vision. The dark flow is not just a measurement, it is an invitation to wonder whether our universe is only one part of a grander whole. It is possible, of course, that future data may soften these mysteries. Some evidence suggests that the dark flow might be an illusion, a statistical mirage. Others think that as we map more galaxies, we will uncover ordinary structures sufficient to explain the motions we see. But even if that is true, the lesson remains. The universe is structured on scales so immense that we are only beginning to glimpse them, and each glimpse reminds us that the unknown is not far away. It is pressing on us from every direction, shaping the path of our galaxy, shaping the flow of the cosmos itself. To stand under the night sky and know this is to feel both small and infinite. Small, because we are a species bound to a single planet, riding a galaxy carried on invisible currents. Infinite, because our minds can stretch beyond those limits, can imagine what it means to be pulled towards something beyond sight. It is in this tension between knowledge and mystery that the wonder of cosmology lives. The Great Attractor and the dark flow are not just puzzles for astronomers. They are metaphors for our own search. We are pulled, all of us, toward unknown horizons, guided by forces we do not fully understand. We may never see what lies at the end of the journey, but we feel its influence nonetheless. And perhaps that is enough, to know that reality is larger than we can measure, to know that our story is written on currents that flow beyond the boundaries of light. And if gravity can reach beyond our cosmic bubble, then what about time itself? Could it also stretch and bend in ways that reveal hidden truths about the universes beyond ours? When we think about the universe, we often imagine it as something outside of us, vast and remote, unfolding in a silence indifferent to our presence. Stars burn, galaxies collide, black holes consume, and the great expansion carries on without pause. Yet hidden within this cosmic theater lies a more intimate and perplexing question. What if consciousness itself is not separate from the universe, but woven into its very fabric? What if the ability to experience, to perceive, to wonder, is not an accidental byproduct of matter, but a fundamental aspect of reality? This is not a new question. Philosophers across centuries have asked whether the mind merely observes the cosmos or whether it somehow participates in its unfolding. In the 20th century, as quantum mechanics revealed the strange and counterintuitive behavior of particles, the question became more pressing. At the smallest scales, reality does not behave like the predictable machinery of classical physics. Instead, particles exist in a haze of probabilities, not fixed until measured or observed. Some interpretations suggest that consciousness plays a role in this collapse, that the act of observation helps bring one version of reality into being. It is an unsettling thought. Imagine a particle suspended between possibilities, here and there, spinning this way and that, until an observer looks and suddenly the particle chooses. Does the universe wait for us to notice it? Does our awareness act like a light switch, illuminating one outcome while extinguishing all others? Of course, not all physicists agree. Many argue that consciousness is not required, that the measuring devices themselves are sufficient to force the decision. Others propose that every possibility still exists, branching into parallel universes, with consciousness simply riding one path among many. But even in these alternatives, the question of mind does not entirely vanish. For if we live in a reality where countless universes blossom from every moment, then what is the role of the observer who experiences one thread while countless others unfold unseen? There is also the deeper question of why the universe is comprehensible at all. Out of all possible structures, why does existence give rise to beings capable of contemplating it? The laws of physics could have produced only barren landscapes of radiation and chaos. Yet here we are, not only alive but aware, tracing equations on blackboards, whispering questions into the dark. It is as if the universe has arranged itself in a way that allows it to look back upon itself, to hold a mirror up to its own infinite face. Some thinkers go further, speculating that consciousness is not emergent but elemental. In this view, awareness is not simply a property of brains, but a basic ingredient of reality, as fundamental as mass or energy. This idea, known in philosophy as panpsychism, suggests that the spark of experience runs through the cosmos at every level, perhaps faint in atoms and radiant in minds. If true, then the universe is not a cold mechanism, but a living field of awareness, unfolding itself in countless forms. In the realm of the multiverse, the implications become even stranger. Imagine other universes where the relationship between mind and matter is reversed, where consciousness is not shaped by physical laws, but shapes those laws instead. Perhaps in such places, thoughts themselves could sculpt reality, dreams could become solid, and the boundary between inner and outer would dissolve entirely. These may sound like fantasies, but they arise from a serious question. If universes can differ in their constants and structures, why not in the role they assign to consciousness itself? Even in our own universe, the mystery deepens the more we look. Neuroscience maps the brain with increasing precision, yet no scan can fully capture the raw feeling of being alive, the taste of a strawberry, the ache of longing, the sensation of wonder beneath the stars. Somehow, within the folds of gray matter, the spark of awareness ignites. To call it an illusion does not satisfy, for even if it were, the illusion itself must still be experienced. Consciousness is the one thing we cannot step outside of, the canvas upon which all else is painted. And so the universe turns inward. The galaxies and black holes, the voids and flows, all may be part of a larger story in which consciousness is not an afterthought, but the central player. Perhaps the cosmos is not only expanding outward, but also awakening inward, finding ways to perceive itself through us. Every thought, every moment of awareness becomes a continuation of that great unfolding. This does not mean we are the center of existence in the old sense, but it does suggest that our role is not trivial. We are part of the universe's way of exploring itself. Tiny islands of awareness adrift in a vast sea, yet connected to the sea by the very act of being. The mystery of consciousness is the reminder that the line between the observer and the observed is far thinner than we imagine. The cosmos is not only out there, but also in here, within each flicker of perception, each breath of awareness. Consider the quiet paradox. We search for the origin of the universe, yet that search itself requires a mind to ask the question. Without consciousness, there is no question, no curiosity, no universe in any meaningful sense. Reality would exist perhaps, but it would be silent, unregistered, without witness. Consciousness, then, is what makes the universe more than just a blind expanse of matter. It is what transforms existence into experience, what turns chaos into story, what makes the cosmos something that can be known. Some physicists and philosophers even speculate that consciousness could play a creative role, shaping reality not only in the quantum lab, but across the arc of time. If awareness is woven into the structure of the universe, then our act of observing, of wondering, might be part of the very process by which the cosmos evolves. This idea may be beyond proof, but it stirs a thought both humbling and profound, that the universe is not complete without us, that the act of being conscious is itself a cosmic event, as significant in its own way as the birth of stars. Take a moment to reflect on this. You, sitting here, listening, are the cosmos reflecting upon itself. Your awareness is not separate from the galaxies or the dark flow or the hidden dimensions. It is part of the same story, written in a different language. To experience is to participate, and to participate is to belong. And so, after all the galaxies, strings, and bubbles, we arrive at the quietest yet deepest mystery. The role of consciousness, the question of what it means to be an observer in an infinite sea. The recognition that perhaps the most profound frontier is not at the edge of the observable universe, but within the very awareness that dares to imagine it. And as our journey draws toward its close, the vastness of it all begins to soften. The rushing galaxies, the infinite horizons, the wild possibilities of other worlds. They fade into a kind of cosmic hush, leaving us with a single, lingering thought. The universe is not only what surrounds us, but also what awakens within us. The observable universe, just a bubble in an endless expanse. Beyond its walls lie forces we cannot see, flows we cannot measure, and possibilities so vast they blur the line between science and philosophy. Perhaps galaxies drift toward unseen structures. Perhaps other universes collide and leave scars across the sky. Perhaps each black hole is a womb for new realities. And perhaps consciousness itself is woven into the fabric of it all. The deeper we look, the less certain things become. Yet in that uncertainty lies a quiet beauty. Because the night sky above us is not just an end, but an opening. A gentle reminder that what we see is not all that is. That beyond the horizon, new worlds, perhaps infinite, may wait. So as you drift into sleep, let these thoughts linger like stars fading into morning. The mysteries remain unsolved, the questions unanswered. But that is their gift. They invite us not to finish the story, but to dream it forward. And maybe in another universe, another version of you is dreaming the same dream. Good night.